Okay, so continuing on with constitutional isomers. Let's take C5H10. Again, remember CnH2n. Okay, so here CnH2n would be C5H10. Therefore, you have an alkene. Okay, and if you have an alkene, you have one double bond or one ring. Okay, that's how it goes. One ring meaning cycloalkane. Okay. So once you know what you're working with, then you can start drawing out your isomers. So here we go. Let's start with the simple one, which means 5 carbons. So 1, 2, 3, 4, 5. And then you go ahead and put a double bond in a location. I take it very systematically, so I go ahead and just move my double bond at one time, and then I'll move my carbons at another time, and then I'll go on to a whole different functional group. So let's go ahead and do the double bond at this time. So we have 5 carbons again, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Move the double bond to this location, and then let's see what happens if we move it to another location, and it seems like we have these two compounds as the same. Okay, so 1, 2, 3, 4, 5, and the double bond here also is on the second carbon, and that's what matters. Okay, it's not the numbering, because the numbering we will learn, of course, but when nature looks at it, it only sees that there's a double bond on the second carbon from the end, okay, from the terminal carbon. So here exactly it's the same thing. So these two are the same, which means that I can only draw 2 isomers with the different locations of the double bond. Now I'm going to move my carbon, so 4 carbons now, because I'm going to move 1, but I also need a double bond over here. So I start with a simple one, move my carbon to the first carbon, then I move my carbon to the second one, and that's all I can do. Now I can try and move my double bond. And here we can get another one, and let's see what happens if I move the double bond here, and it turns out that these two are the same. I would suggest when you draw isomers out, do not erase anything. Okay, number all the isomers you're getting, and then that way you can see which ones are the same, which ones are different. So this is A category, this is B category. Now in C category, I'm going to go to cycloalkane. Cycloalkane means I have 5 carbons, so that's my first starting point. If you're not quite sure, you got all the hydrogens, go ahead and count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then the next structure would be where you have a cyclobutane and a methyl group. Again, if you're not sure of your carbons or of your hydrogens, count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you follow the rules, you should not really have any trouble. That's all you can draw for cyclobutane. So let's go on to cyclopropane. And now you need to have 2 methyl groups to have 1, 2, 3, 4, 5 carbons. Now the location of the 2 methyl groups can vary. Okay, so you can have that, and of course by the time you move it one more time, these 2 will be the same. Okay, so essentially we have 1, 2, 3, 4, 5, 6, 7, 8 isomers. Okay, for C5H10. All right. Let's take another one, C6H14. Let's go ahead and do the CnH2n for this, and the CnC6H12. And then, of course, we have 2 more hydrogens here, so plus 2H, which means we have an alkane, which means all single bonds. And when you have all single bonds, it means you really cannot go to, when you have an alkane and you have all single bonds, you cannot go to a cyclic structure. Every cyclic structure, you lose 2 hydrogens. So C6H14. Now we go ahead and draw 6 carbons out. 1, 2, 3, 4, 5, 6. And then start moving 1 carbon around. So then you draw the chain for 5. 1, 2, 3, 4, 5. Move 1 carbon. 1, 2, 3, 4, 5. And then draw one more. And then if you want to try this out, you can go ahead and do that. But you know that this one and this one, these are same. Okay, because the methyl group is coming on the second carbon. Methyl group is coming on the second carbon. Okay, all right. So then let's go ahead and try moving 2 carbons this time. So now we draw, since you started with 6, now you'll start with 4 carbons because you moved 1 carbon with 5 chain. Now with 4 chain, you will move 2 carbons. So 1, 2. So 1, 2, 3, 4, 5, 6. Okay, you have 6 carbons. Now you can move them in a different location there. You can try one more if you want, but you know that these 2 are going to be the same. Okay, so that's kind of how it goes. You can try something ridiculous if you want to, or say, okay, let me have 3 chain, and then let me go ahead and put 3 carbons on it somehow. 1, 2, 3, 4, 5, 6, but then you will see that this structure and this one are the same. Okay, so it's better to keep things systematic, and it's also better to keep things in order. Let me go ahead and do the nomenclature also right away as we are working at this, because this is the best way to learn nomenclature as well. So this is hexane. This is 1, 2, 3, 4, 5 pentane and 2 methyl. So this is 2 methyl pentane. This is 3 methyl pentane. One of the best ways to check if you have different structures or the same one is to name the compounds. Okay, so when you name them, you will figure out whether you have different compounds or not. So for example, this one here will have the same name as this one, okay, over here. So then we know they're exactly the same. All right, so this one is 4 carbon, and in the second one you have 2 methyl groups. So this one is 2,2 dimethyl butane. This one is 2,3 dimethyl butane. This one again will be 2,2 dimethyl butane, because this is 1, 2, 3, 4, and on the 2 you have 2 methyl groups. And again, when you're trying to name this one, you'll have to take the longest chain. So just because you drew it this way doesn't mean that this is the longest chain. Okay, so you have to find the longest chain, which is 1, 2, 3, 4, or 4 on the other side. Okay, and so then you will realize that you have 2, 3, you have 2 substitutions. Okay, so by the time you do the nomenclature, then you'll know that the structure is the same as the one above.